Great. So hi, everyone. We are Our Ladies Room, and today we will have a session on data wrangling practice with R. Our speaker is Federica Gazzelloni, who was just now saying hi to all of you. And well, as a disclaimer, this talk is recorded and will be posted on our YouTube channel at Our Ladies Room. Feel free to turn off your cameras if you do not want to be recorded. And of course, we prioritize creating a safe and inclusive space for everyone, free from any form of harassment, and fostering a respectful environment so we can all learn from this experience and connect. And of course, then this means that you are all expected to adhere to our code of conduct. You can check it out in ourladies.org/COC. And you can use the chat, of course, to introduce yourself as we were doing and to ask questions as Federica goes along. What you can expect from this talk or hands-on session, as Federica was saying, is basically some hands-on learning to engage in interactive exercises using our packages like dplyr and tidyr to clean, transform, and organize datasets. You will also learn about some practical techniques, discover essential data wrangling techniques and best practices that will help you to manipulate and do your analysis. And of course, also networking opportunities. Via chat, you can always connect with fellow participants and data enthusiasts, sharing insights, experiences, maybe thoughts that you have around how to do something or collaborate. So we are happy to welcome you to our September event. We tend to have monthly events. I'm Silvana Costa, one of the organizers of Our Ladies Room, and we are thrilled to have you join us today. We are also with Rafaela here and Federica Gazzelloni, who will be sharing her insights and expertise in data wrangling with R. And basically, well, I mean, what is Our Ladies? We are a global community with a mission of promoting the R language and empowering women at all user levels by building a collaborative global network. It is a friendly community founded in 2012 by Gabriela de Queiroz in San Francisco. And so Our Ladies Room is a chapter of Our Ladies Global, and it's dedicated to promoting inclusivity in the R language community. And our monthly meetings are a platform for us to discuss, connect, and learn about current trends in R. Our Ladies Room is a well-known, recognized community since January 2023. So in the last 2 years, we reached more than 1,000 members with more than 1,600 RSVPs and 20 plus events organized. We tend to host our events online. And this, as Federica says, means that we are spread all over the globe, as you could see in the chat. As for the team, the founder of the chapter Our Ladies Room is Claudia Vitolo, and the co-founder of Our Ladies Global. The lead organizer is Federica, and me and Rafael are also organizers here in Our Ladies Room. Well, so here you can check, and also in our website that we were sending the link, you can check some of our past events. So we had an event with James Wade about building a chatbot, with Janon Pileggi about debugging in R, I don't know, with Hadley about R in production. And yeah, our last one was with Bruno Rodriguez about pipelines in R, Docker and Nix. And now we have Federica with data wrangling practices in R, just so you have an idea of what type of events are we hosting. And yeah, as for future speakers, stay tuned via our meetup and our social links. As for future speakers, we will have Julia Stewart-Lowndes, which is the founder of NASA OpenScapes project, probably November 18th. So stay tuned for that. Well, now it's time to present our speaker. Federica is a skilled data analyst with a passion for R programming and data manipulation. She has extensive experience in data wrangling and a strong understanding of key R packages such as dplyr and tidyr, and she's dedicated to helping others enhance their data skills. So in this session, she will guide you through practical exercises that will boost your data wrangling skills. And basically, you will be learning about cleaning, transforming, and organizing the data sets, and a lot of things. So with further ado, let's get started with data wrangling practice in R. So Federica, the floor is all yours. I will stop sharing screen.
Thank you. Welcome, everyone. So let's get started, and I'll show you what is going to happen today. Okay. Okay. So today, what we are going to practice is the data manipulation, transformation. There is no strict requirements for this tutorial. It's very important that you know the R environment because it's out of the scope of this course to introduce you to R. But that will be enough to just to get started and start practicing a bit how to manage and deal with data sets that we might need to arrange, modify, change. And so I put in the chat this website, which is the what we are going to do today, and hope this is going to be useful. As well, we have a GitHub repo, so it's up to you if you want to download or fork the repo to have all data and things that we do today. So our learning objectives are to understand the importance of data wrangling, which is a big step in the data science workflow. And we learn how to clean and manipulate data and handling missing value, tidy data, reshape dataset, and prepare final dataset, export dataset for a future use. Okay, so let's get started. I'll put everything again in the chat just for your reference to have the material. And there you go. Okay. So share my R. And here we get started. So the data that we use today are data that are from Kaggle website. And I didn't put this in the chat as well, but you have everything in the website, in the lesson website. And so our basically what's the main introduction to data wrangling is just to give you a little idea, is it is not only, so the data wrangling name in itself includes other further transformation of the data. And we can say that we are, when we perform data wrangling, we can say that we deal with data in a way that we can completely adjust and transform. So we can divide the process of preparing data for your data analysis within three main steps. which are data wrangling, data manipulation, and data transformation. Basically, we will go through these steps. There is a very thin difference within these three subgroups of data preparation, and basically the wrangling in itself, the data wrangling itself includes handling missing data, dealing with duplicates, and standardizing data formats. It's fun to say that data wrangling is also known as data merging, which refers to the process of cleaning and organizing raw data. So your data as a starting point to make it suitable for the analysis. Then data manipulation is a it's like a bit of it's a part of data wrangling, but it's a further step to data wrangling. So builds on data wrangling by adjusting, filtering, and transforming data. So you filtering data, sorting, grouping. So all that verbs that belongs to the tidyrs. Okay. Then finally is the data transformation. And here we are going to reshape data completely using, again, other verbs that are changing the shape of the data set. You can also do like sort of normalizing data or apply mathematical operation. We don't do that on this example, but we will see something very similar. Okay, so now I'd like you to have a look at the data set. If you had the opportunity to open up the Kaggle. We also have a bit of information such as the data description in the lesson. So it's all inside. I open up my project. And so we can see that we have the data here and further data that's row in here. So we are going to start with a clean script, and first step is to load the tidyrs. The tidyrs, it's meta package. So for this reason, it's very useful because we don't need to load, for example, ggplot2 or dplyr or tidyr, because they are all included within this package. So you load the tidyrs and you will be equipped with all the other packages. Okay, so let's start by loading the data, and as we can see, if we open up lesson here, it will appear in the viewer pane, so you can see it as well as we go through the process. Okay. Okay, as I mentioned, so we are going to use the cardio trained data from the Kaggle, and this is the what is inside. So we have age of the patients, the age, the weight, the gender, the systolic blood pressure, diastolic blood pressure, cholesterol, glucose, smoking, if it's smoking or not. And so all this information, as well as if there is or not presence of cardiovascular diseases. So the cardio train file is in the data folder and comes as a zipped file. So you can use the unzip. As we can see, we can use the unzip to unzip the data. Okay, and then we can see that, okay, I obviously I already have that in my folder, and so we can use the read CSV function. And this is, let's say, the first step of, this is from the readr package. The first step is collecting data. So we can use this from with underscore, which is from the readr package, or we can use the read.csv, which is from utils, and it is one of the base R packages. The differences between the two is very little, but sometimes it's very useful, one respect to the other. So if you are curious, you just type a question mark before the function, the command, and in the help tab, you're provided with all information about the function. Okay, and so you can catch the differences. So in this case, our cardio train cannot be loaded directly this way. Okay, because if I do this, I have that in my environment now, and I can have a look at that. So as you can see, this is the how the read_CSV function has read this data. So we need to specify that there is a semicolon to separate the information. So it's you know, straightforward to use the .csv, the read.csv function from the utils package. It allows, in this case, to use the SEP option. Okay, so I can just do SEP, and I can specify the semicolon. So this time I can just rerun by command enter. I can run the command, or I can click run on top here, and the cardio train in my global environment has changed, and now, as you can see, we can see it clearly because we provided the correct separation element. So this is a way to have a look at the data set, just as the same as in Excel. And if we click on this tabs, we can arrange it. And so we can see that we have two genders. The age is in days, as mentioned in the description, and then we have the weights, so the ID and various information, and as well as the presence or not of cardiovascular diseases. Okay, let's go forward and see what else. So we have seen it this way. If we want to see just a little, such as few rows of the data set, I can clean my console here. We can see this way. Okay, let's do it again. Okay, so here we can see the first 6 rows. And so we can also do the structure, the str function to see the structure of the data set. So we can see that we have some integers, some numbers, even all the variables are already somehow, this data set is already cleaned, okay, for some use, but we might need a different type of usage. So we can change it. Some variable can be transformed as a factor. The age, for example, can be transformed as a years, and so on. So we can do many things. To just follow what I did it here, for example, here instead of the str function, I've used glimpse, which is exactly the same, but as a different format. So it's up to you which one. Sometimes I use one, sometimes I use the other one. So the first data wrangling in itself include handling missing data as a first step. So in this case, we don't have missing data. You have a different way to check if a data set has missing values. And for example, I like, there is a package which I like, very much, and it is Data Explorer. And so then you can use this function from Data Explorer. You usually install packages with the function install packages, and then you put within the quotation the library that you want to install, and then you might want to load the packages. You can do library, but otherwise, if you don't want to library, so load the entire package, because you don't need all the function in a package, you can just use this double colons and call the function that belongs to the package. So we don't use this too. And so usually I use this Data Explorer package because it turns a nice table. In this case, this dataset doesn't comes with any missing values for now. Then when we make some modification, they might arise. But in case they were listed here. Okay, so going back to where we were, then we can see if it's the data set as eventually so we didn't check about the dimension first, and so we can see we have like 7,000 observation and 13 variables. Then we might want to check if there's any duplicates, and we can use the distinct function. And the distinct function, anytime you want to know more about function, you can do just a question mark. It's from the dplyr package, and basically make a selection, keeping only unique and distinct observations. And then I use the dim function again to see if there's any differences within number of observation in this case, so we don't have duplicates. Okay, you can even use n rows, so for counting the number of rows, and so you will be your output will be just 7,000. And so now we just had a quick scan within the data, and these are our raw data. Okay, a good practice is I have Copilot, so a good practice is to name the raw data with another name, just to preserve the raw data as is, do not make modification. So we can call it cardio, for example, and then perform all the modification on the new data set. This way, what I did it here was just renaming the data set, which if I have a look at the environment, now I have cardio train and a cardio, which are exactly the same. I can have a look at cardio, and exactly the same as cardio train. And so now I can change, modify, and do whatever I like on this new data set without compromising my raw data in any way. So the next step, after first exploration of the data, so we had a look that we had some numbers and no factors at some point, so they might be useful if you then want to make a model and do further analysis. So now we are going to standardize this data, passing through some interesting functions such as mutate, or which allows you to make modification to some data, but even allows you to create new data. But we will see later, to create new data is a first step. So then we can change the class of a variable with this as.dot function. So, and for example, transforming as a factor instead of being just a number. Generally, for example, gender can be a factor, or if it's the interest, it's cholesterol, which is of 3 levels, can be cholesterol put as a factor, and as well as if the presence of cardiovascular disease is yes or not, it must be a factor. So the first modification that we do is to create a new variable with the mutate function, and we call it age years. And this age years basically uses I can do just age divided by 365.25 if we want to be precise and everything. This way I would obtain, just do use the select function to select the first two, and then head, just to have a look at what is this modification. So now the age in days is now in years, but we still have some, need to round this number to be an integer. And so to do that, we can use the round function, and the round function is another function which is quite useful, and it's used quite frequently. Here it's from the base R, and you can specify even the number of digits that you want to round your number with. So quite straightforward. All the function, all the commands, as I called verbs within the tidyverse ecosystem, have names which are quite straightforward. So you can recall them quite easily. And so it's a language which is understandable. And just to this is a part which is very important. When you learn a language, and you might experience difficulties in recalling the name of the commands or the way to use them. And my personal experience is that I found in R a way to learn these things quite easily in some senses, but for what easy can be learn how to code. But when you need something, you have many options. Think about a suitable name, and it most probably will be that. You can Google it, you can use ChatGPT, just put any query you have, any issue you have on a Google Sheet, on a ChatGPT, and ask your question, and you will receive most probably the answer that you are searching for. So just going back to where we were, so we use this round function, and now things changed a bit, and the years are integers, though we haven't specified them to be integers, and we can even do that. We can see, for example, we can use the function as integer and specify that what we want, basically. Okay, so we can see that age is an integer, but age years, it's a number because we rounded. So the specification of the number is still there. So if we want to have age years as integer, we need to specify for them to be integers. And so we can do like that, equal as integer, and now age year is an integer. And so we don't store that rounding bit that we had before. If you, in case you have any questions, please put them in the chat. I'll be happy to answer your questions and help you out if you have any things in mind that we haven't mentioned within this tutorial. Okay, so we have already seen the select function, which is part of the data manipulation part. So data wrangling, as I said, can be divided within three steps. The first is data wrangling, then is a further improvement, let's say, of data wrangling, which is data manipulation. And then we have data transformation. Part of the data manipulation are functions such as select or filter. And so we basically, what we do when we manipulate the data, it's subsetting our data set. Okay. So in this case, we already use the select function, but we can do a bit more, such as having select these years. Okay. And then instead of using, let's copy and paste this again. Instead of using the structure function, we use filter, and we specify age years, for example, to be greater than 50. Okay, so now it's the entire information that comes up, but if we use the head function, we can just have the first rows. We are not sure if the age years is arranged from the lowest value to the highest. And in fact, we can see that we have 55 and 54 here. And so the arrange function is a function that we use later on within this tutorial. And it is a further, part of the transformation section of the data wrangling. So this is a way to subset column, but it is not the only one. So there is even another function, which is subset, which sometimes is turned to be very useful. And this can be slightly adjustment of this function is from data table package, but it is from base R. So for example, if we can we have a look at the subset in itself, we can see that we can use a way to subset the data set only in one row. Okay, so in this case, if I wanted to subset the cardio data set, I will do like that. Okay, but I haven't made modification of this data, so I might need to do age, in this case, just to show you what is it, and put the number of days. So I will subset cardio when the age is 21,250 days greater. And so here is the subset. So this type of function, the subset, turns to be useful when you subset within inside other functions, or just to have a short way to subset when your data set is already done. I usually use the tidyr way, but sometimes this can be useful. Okay, so another important step is grouping and summarizing data. So the first time I learned group by and summarize, they looked very difficult to me, very difficult to understand what's happening within this grouping things, what is summarize. And so it took a bit, okay, to get used to it. And now, you know, it's just very useful, and I use it very frequently. And I don't know how to do without group by and summarize or reframe, which is the new function that has been released after summarize. So group by, if we have a look at this, I can use, I usually do that, might be not the most correct way. So the view function allows you to open up the same data set that you would open from the environment clicking in here. You can use the view with a capital letter, for example, and it will open up your data set. So if I have this data, I might want to see what is the mean age, in this case, because we made a modification of the age to be age in years. What is the average age by the level of cholesterol? So I group this data. Where is the cholesterol? Okay, cholesterol has a three level, 1 to 3. Okay, which is, you know, the increasing level of cholesterol from the lowest to the highest. And I can group my data by these 1 to 3 levels, and then summarize the data by calculating the average value of the age, the weight, and the age. For example, this is a way to use group by, and there is other ways, but let's just take this bit. Okay, and then we use group. So we grouping. Okay, now Copilot suggested to group by age, years, but I don't want to use, I want to use cholesterol. So if I just have a look at this and the head, okay, just the first few rows, nothing happened basically. Okay, it's still entire. If I have a look at dim of my data set, it's still 7,000 rows and everything. But as you can see, the table has changed, and here there is a specification. So the data is now grouped by cholesterol, which has 3 levels. So now the function that I use after group by, I can use different function. It's not that I can use mutate. Oops, I can use mutate and create a new variable based on this grouping, or I can just summarize. And this summarize is as well creating, for example, in this case, creating new variables, but at the same time, it does a selection. So summarize is mutate and select. So now if I use summarize, for example, here I use the suggestion from Copilot and do I require new variables to be created as the mean of the age, years, the standard deviation, and a count. Because if I use n within the brackets inside the summarize function, I count the number of observation within each group of cholesterol. Okay, let's just run this bit. Okay, you can see that now I have the three levels of cholesterol and the value of the mean age, the standard deviation, and the counts. So how many observations I have in level 1 of cholesterol. And this is done inside the summarize function with the n. This is a function which counts, provide information, so basically counts the data within each group. If instead of using summarize, I would have used mutate, and let's take its suggestion. Okay. Now, and then I haven't said everything, because here their data is still grouped. Okay, and this has a meaning, but I'll go back to this later. So if instead of using summarize, I'll use mutate and ask for the same things, we'll see that we have, let's see, dim all our data set with 17 observations, not only 3 times 4. Because mutate, what does is, so we now have the 17 columns instead of 13. We add 14 because we add 8 years. So we add 3 more variables. But we left with all information. And this is very important and useful at the same time. Data is grouped by cholesterol, but so basically the mean has been, let's have a look at this view. But you can see that we have the mean age, which is not rounded as we might want, is now the mean of the age of those who have cholesterol level 1. And if I go to another level 1, I have the same mean age. And so it depends by your needs, but you might want to use summarize, or you can even filter by group or any other function that will change the data set while it's grouped. Okay. But now going back to what I was saying, once it's grouped, data might need to be ungrouped. So and nothing changes basically. So to jump this this step to ungroup the data, a new function has been set, which is instead of using summarize, we can use reframe. So now if I use reframe and reframe, now my data, okay, here I cannot see it, but it's not grouped anymore. Instead, if I use summarize, I will need to do ungroup if I want to ungroup the data. Okay, this is basically the main difference between summarize and reframe. There are other options that we can do. Okay, so let's have a look at this again, cardio. Okay, so we already seen that, and it is this data set. If we have a look at the first rows, okay, eventually I can position it, this new information after age, for example. Okay, so now the new variables I created are relocated just after the variable I specified. And relocate is another function that we can use. In fact, we can use relocate and specify, for example, n to be relocated. And look what's happened if I do that. That now n is the first column. So yes, if you come from Excel and jump into R, at least this is my personal experience. When you see this, you say, oh my gosh, how can I do that? Because in Excel, I'm used to, grab the columns, bring it on the left, changing the things. Now I need to perform a command. I don't do that manually anymore, but I use a command. And it might take a bit, but it's worth all the time spent on it because it's stable, more robust. So errors are reduced, basically. Okay, so let's, I don't know if you have any questions. Let's go forward, and we have already seen that, how to create a new variable with the mutate function. Obviously, if you are still not satisfied, you can always question mark and dig within the documentation. In the lesson where the reference are, there is also more about the tidyver's website and everything that you can have a look at for more information. Okay, so now we can create a new variable ex novo, because what we did it here was a modification. Okay, we created a new variable, but we created a new variable of the same thing. What we can do now is created a new variable from the weight and the age, and so the BMI vector. And so this bit is always our point to start. So we just copy this, and then we don't need to exit the mutate, but we just can do BMI and body mass index, which is done by weight divided by 8, because the weight is in kilograms. 8 has to be transformed this way. Okay, so this is done like that. I don't think it's okay. So we can just I don't know why it's have a look at this. Okay, and so we have our body mass index in here. So these are basically the basics of the transformation. We already seen how to use the filter. Even in this case, we can, for example, apply a filter. And so we filter by all the BMI that are greater than 30, and so on. So now what I wanted to show you is that obviously we can make visualizations once the data set, you know, you made your modification and everything, then you can do a visualization to see what you want. So in this case, what we did it here was to set the gender as a factor. If you can see here, we don't use this as dot factor function because there is a slightly little difference between the two. In this case, as we want to specify the levels and the labels, we set them as to be a factor, okay, this way. And so we can specify the levels and the labels. And then perform a visualization. The fact that we specify gender as a factor is very important for this visualization to be as is. Because if it's not a factor, it's not doesn't turn to be just as the same as appears in here. Okay, let's have a look. If I don't do this, okay, and as you can see, we cannot see. I can even specify the factor inside the visualization. And now you can see. But the way we did it here allows us to set the levels. And this turns to be very useful when you do modeling, and also the labels. So when you see it's not 1 and 0 or 1 and 2, but you can change the name of the legend as well. So it's a lot of information, and you have the everything in the lesson. So in the recording, so you can go back and have a look at all the things. Finally, sorting data, you know, the arrange the function allows us to, you can use descend for descending data. For example, this is the maximum, the highest number of years was 65 for this data set. And we can use arrange and inside descend to arrange the age years from the highest to the lowest. This is another way. Okay, so here there's a further
Federica,
yes,
there is a question.
Yes.
About the levels.
Yes. I imagine. Okay.
We already assigned labels with the level option now.
Yes. In this case, specifying the levels, we assign the levels. Okay. There is a function which is relevels to change once you have set the levels to relevel the factor on, for example, female to be 2 and male to be 1. Okay. And this is the for experience, the best suggestion that I can give you is just to play with it a bit. So just take a fact, take a variable and see with because there is also a function which is called class. Okay, for example, if I do cardio, I can do $sign and gender. Okay, say gender here. Okay, and so this way the gender is now one vector. Okay, then I can do as factor gender, and now this is a factor. How can I see if it's a factor? I can use a class function, and this is a factor. Instead, what was before, I can even do class and inside gender. Okay, and it was an integer. Now, if I'm, instead of doing as factor, I do factor and then gender, and then I specify, if I do tab, now I have Copilot, it's somehow difficult. Okay, if I do tab, beside the factor function, there are all the options that can be used. So I can specify the levels and say 1 and 2, and that would be enough. Okay, or I can just, as I did it here, specify that female is 1 and male is 2.
But Federica,
Yeah.
when you specify the levels female for 1 and male for 2, it isn't automatically the number 1 female and male. You need necessarily to label as female and male.
You if you, for example, if you make a visualization and you want that within the legend it will appear female and male instead of 1 and 2, that would be useful, but not for only that, because maybe when you do modeling you might want to have the reference clear. Instead of having 1 and 2, you have, instead of having gender 1 with this coefficient, you might have female as a reference, which is visually more clear, as well as you can relevel, and when you want to see what changes if male was 1 and female was 2 instead, you can use the relevel function. So basically, I can, as I said, use the label. Okay, now it's not needed, but there is a level function, okay, from the stats package, which reorder a level of a factor. And if you for example, this is useful. You can even, you know, put, specify which one is the reference. In this case, if I now assign this to the variable, so now the gender is done, is not an integer, but it's now a factor. If I have a look at the level, gender, levels, okay, levels, it says what are the levels of this variable. But because I specified, when I set it as a factor, if you don't do that, if you do levels, it said none. Okay, so this is in the documentation here, there's more grouping and things, and you can have a look at that. It's quite you know, interesting, and even a specification with a visualization, which is a bit out of the scope of this lesson, but we can go back to that. I like to go forward because otherwise visualization will take a bit. I haven't talked too much about the summary function, which is also very useful, and you can use it to have a quick look at the statistics of all variables, or another way that you can do is, for example, you want to know just about the age, okay, and the weight, so you can do pull. You can pull out the age and then do the summary. And so you have just the summary of the height. You can use the pull function to extract just the height. Otherwise, you can do cardio and 8 and the summary. This is another way to do the same thing. Okay, so this might be useful. Another useful function is this map data frame, which is now a bit of like there are some adjustments on the maps function, which are from the per package, which is now inside the tidyr meta package. And so you don't need to install the per package because it's already inside. And what does this map data frame with the summary inside? It's a list, a nice, instead of having a summary as we saw before, this one here, we have a nice table to look at. So you have the mean, the median, the mean, etc., and with all the variables. And so you have this in the lesson. You can go back if it's interesting to you to see how it's done. There are a couple of extra functions, column to row names, and I also use very, very often this janitor clean names. We haven't mentioned it, and this is something that it might go to be used at the very beginning. But in this case, the cardio dataset, the names, they were already cleaned. And what does is basically create the column names this way. So with an underscore dividing the things, and they are all low letters. So low capital letters, no capital letters. Okay. finally, I wanted to, here are other footer modifications. So I set them as a factor. We already talked about this factor. I like to jump into this data transformation. So together with grouping, as well as the joint functions, are somehow, at least in my experience, have been a bit of, tricky first time I saw them. But then, you have the merge function and you solve all the issues. Okay. This, what's happened when you use them, when you have two data sets and you want to combine them together. Okay, here I haven't shown you images of how the data set combines together, because you can find tons of information on the internet. So you can imagine you have a data set and you have a second data set, and then you want combine them by an index. So a column, a vector that they have in common. And so we can do that with a simple merge function, or, and this would be basically combine all the information from the two data sets. But we have other options, such as the left, right, inner, and full join. There are many joins functions. You can have a look at the documentation and you find. So basically the left, how you use it is to show you how to use these things. What I did it is basically loading a new data set. So here, what I did it here is take the cardio data set and do all the modification that we did it before, but I did a footer adjustment because I wanted to merge this to a new data set. And this data set, you can find it in the data folder, is the cardio deaths. The cardio deaths are a list of data sets. You have a folder in the scripts, in the project. You have a folder named scripts, where there is a deaths row script, where I basically shown how I've collected this data and put them together. These are data from the HME. And so we also had issue with the tool for downloading data. So what I did it was to basically HME data. I downloaded little bits of each part, such as I downloaded the data, the death rate for due to cardiovascular diseases for age group 5 to 14, 15 to 14. I just asked the same 50 to 69 and 70 plus. Okay, for female and male. And so I had all these bits because I downloaded from the DataVits website. We can even, so if you go to healthdata.org, there is a DataVits things. It's everything in the lesson, in the resources in here. Okay, you have you go here. and you'll find where to download, look at the visualization, and then eventually download the data. Okay, so basically what I did it is downloading all this little bit. Okay, and then I listed the files in the data folder with the list.files function. And then I use this function lapply to read all the files and then put them together with the do.call function. Okay, you can, this is outside the scope of this tutorial. So you have the script in the script folder for you to have a look at. So I made some wrangling things to finally have the data set that we use here. Okay, and in fact, the data set it's basically this one here. Okay, and so what I wanted to do was to load this data set, and now we have it in the sorry, because I think it's got an issue. No, okay. And so and we have now in the global environment. So if we go to the cardio data set, we can see how it is, and we have this age thing. The last thing I wanted to show you is how to, because to merge the cardio data set with our data set here, even if we change the age to be age years, we don't have age intervals. So what we need to do is basically modify. Let's take this entirely. What we need to do is basically we know how to create the age years, but not the age group. So we can use the cut interval on the age year, specified for groups, because in the deaths we have 4 groups. How do we know that? We should do cardio deaths and use the count function. This is a function which is counting things, and so we count the age, and we can see that the age, we have 4 groups. Okay, we have a group 1549. They're not ordered because it's a character, so it's not ordered, but we can order it later on. And so we cut our vector age years in 4 subgroups with a specific label, which is exactly the same. And we can even stop here and have a look at age and age group. And have a look at this thing. Oopsie. Okay, so these are the first few rows, but if we do like we can use the count like this, but the age is not counting very appropriately, because age it's not grouping fine. So we can use, okay, age years and age group. Now let's basically copy this again, because it's let's have a look at this this thing and copy this again. So we basically create a new cardio 2, sorry about that, and then merge with that, with cardio deaths. Now that we have created age groups as we wanted, as the same as the same things that we have in cardio deaths. And so let's run this, and then finally merge the two data sets with cardio deaths. So I created a cardio 3 because then I group it this by all variables and then reframe it to create mean values. Okay, just to show you, you can with time have a look at that, and it will be very useful. So just to show you now how to join the two, we can use in this case a right join. Okay, just to going back to left, right, and inner join. Right means that this the data set is, this one is on the left side. Okay, here this is left side, and then when I do right join, okay, to this other one. So this is left and this is right. So if I do right join, means that I'm selecting all the column. I do a preference, and so this is my K data set. So the join, the merge that I will do within these two data sets will be based on the number of variables on the data set on the right side. If instead of right, I would said left, the number of observation and variables the merge will be based on the number of observation and variables of the left side data set. Okay, instead, if I do inner join, I will do I will take what is in common within the two data sets. If I do full, I do merge. So I merge everything. And so I most probably have some missing values. So it's up to you. There is also an anti-join, so which pulls out what is different between two data sets. So you need to play with that a bit. And so these are the joins. Finally, the last things, and then we stop because it's a very lots of things. It's the tidying data. And so this is concerned with the modifying the structure of the data set, making longer or wider. And so there is more to see. You can have a look at the rest of the lesson. And so for example, it's always very important to check, to have unique observations. But for example, if I wanted to use a pivot longer, okay, which is this one here. Okay, pivot longer means that my table becomes longer. And so I can take two variables, the cholesterol and the glucose. Okay, for example, if I have a look at this cholesterol and glucose and make them to be in one vector, which has the name to be cholesterol and glucose, and the values to be the levels inside. So in fact, we can see the output here. So we have this, we have created a new vector with the names. So names to the name of the column, and the values, the content of the column. And so we made a longer data set with a pivot longer, as well as we can make it wider with pivot wider. And basically what I did it here was the reversing the things. So the names from the exam type and the values from the result. And you'll see if you run this code that this is nested. So the result is a list. So you will need to unnest the two columns to go back to where we were. So I've shown you many things. You have the recording, and there are more information, but we don't have much time to see everything. I'd like to stop here and see if you have any question to ask. And then I would suggest you to eventually watch the recording and go back to the material. Okay, I see that there might be too much information, but my warm suggestion is to play with it as much as possible, and it would worth it. So. Do you have any question to me that I can help you out? Do you want me to show you something in particular?
I have a doubt. When you are combining two data sets, you need to have the same columns and same numbers of rows, or can be different?
No, you need to have at least one vector, which is an index. Or when you have different data sets, you can combine them. I'll show you something. You can combine them in different ways. For example, you can even do bind rows. In this case, you need to have the same columns, exactly the same column, the same vectors. You can use bind calls, and so, for example, I can bind cardio. That's in cardio 3 only if they have the same where is it? Number of observations. Okay, we don't have the same number of observations. We don't do that. We use we can use the merge function. So now in this case, the two data sets have in common just two vectors, the age and the gender. We made an adjustment to cardio 3, okay. Cardio 3 has now age group, just as the same as cardio det, and the gender. So we have two index variable to use for linking the data set together. And they don't need to have the same number of observation. In fact, this is 1,000 and this is 200. In this case, we just link them because of the two vectors with the column names in common, and inside they are the same. So the function will be searching for all the elements, for example, 1549 on this other table and link it together. If I use the merge function, for example, it works for this reason and does automatically. You can have a look at what the merge function does with a question mark, even from base. Okay, it's basically you don't need to specify if you already made an adjustment to the data set in a way that they have a linking vector, you can just use the merge function. But when you on the fly, okay, when you do wrangling and want to join two data sets, a suggestion is to use the join functions, because inside the join function is a bit more customizable. And so, for example, if I put this cardio 3 on the left, and then I do left join the cardio debts, and don't specify anything. Okay, you see? It works because it works. Because I have the two linking vectors already settled. But actually not, to be honest, because in cardio, age is age, and in cardio debts, it's age, while in cardio 3, it's age group. So this is the case to use this, because I can specify by so this is a left join, so I'm interested in cardio 3, and so which in this case is age group. Okay, and age group, it's equal to age in the cardio debts, which is on the right side, and then the other variable is gender, which is equal to both of them. Okay, if I do that now, you cannot see it, but they are 13 variables, and before they were 14, because what did it before was to create a new variable with age. So you had age group and what is it? So which is not linked with, so he didn't link it with age, he linked it just with gender. So the two data sets are not linked by age and gender, but just by gender. So if you want to, if you have two vectors, in this case, we can adjust the name of the vector this way. And now we have it linked to both gender and group. So
Okay, I have a question.
Yeah.
Sorry,
yeah.
but it's linked with that. If you had two different data sets, but they are the same, but in different period of time, and the same variables, when you combine them together, the variables will be in the same column, like the column 1 and the column 2 in the same column, or in the different columns.
Okay, if you have, it doesn't matter if it's time. So it matters if it's time, if you need to deal with dates. And so you need to make a modification to be months or years or year months or so as specified the structure of the dates vector. But if you have different dates and you combine them and they have, you specify the name of the vector in a way that the function knows that this is the same information, that will be merged together. So it's like binding rows. So you find one after the other.
Okay, thank you.
Okay. Okay, so thank you very much. I'm not sure if you have any other questions. Yeah. Thank you very much for joining us. If you have any questions, please do not hesitate to ask. And remind that you have the recording that will be posted very shortly on our YouTube channel. If you like it, just subscribe. And thank you for joining us. And we will see you next month with an interesting event that will be slightly different from this one, not exactly in a tutorial, more a talk. So we will be informing you very soon on our social networks. So thanks for joining us.